Look up into the vast, dark expanse of the night sky. Among the countless points of light, a few wanderers trace their paths. These are the planets, our celestial neighbors, and among them, one holds a special place in our hearts and minds. It is a world of breathtaking beauty, a planet adorned with a magnificent system of rings that has captivated humanity for centuries. This is Saturn. It is a world that seems almost too perfect to have been formed by the chaotic dance of gravity and gas. It is a beacon of wonder, a constant reminder of the sheer scale and grandeur of the cosmos. To truly appreciate Saturn, we must first understand its place in our cosmic neighborhood. It is the sixth planet from the Sun, a resident of the outer solar system, a cold, distant place far from the warmth of our star. Saturn orbits the Sun at an average distance of about 1.4 billion kilometers, or nearly 900 million miles, almost 10 times farther from the Sun than Earth. Light takes just over 8 minutes to reach Earth. It takes nearly an hour and a half to reach Saturn's cloud tops. Saturn's orbit is vast. One trip around the Sun takes a long time. A year on Saturn is more than 29 Earth years. Ancient astronomers named it after the Roman god of time and agriculture. At its heart, Saturn is what we call a gas giant. This means it has no solid surface to stand on. If you were to descend into its atmosphere, you would simply encounter gases that become denser and hotter the deeper you go. Eventually, the pressure would become so immense that the hydrogen gas would transition into a state we don't see on Earth, a liquid metallic hydrogen. It is this swirling, electrically conductive ocean deep inside Saturn that is thought to generate the planet's powerful magnetic field. At the very center, scientists believe there may be a small, dense core of rock and ice, perhaps 10 to 20 times the mass of the entire Earth. The part of Saturn we see is its upper atmosphere, a vibrant and dynamic place. It is a world of clouds and storms, painted in subtle shades of gold, yellow, and white. These colors are the result of trace chemicals and compounds like ammonia ice, mixing with the primary gases at different altitudes and temperatures. The atmosphere is arranged in distinct bands, or zones and belts, that run parallel to the equator. These bands are created by incredibly fast winds. Near the equator, winds on Saturn can reach speeds of up to 1,800 kilometers per hour, more than 4 times faster than the strongest hurricanes ever recorded on Earth. One of Saturn's most enigmatic features is a bizarre, 6-sided jet stream that swirls around its north pole, the hexagon. Each side is wider than our entire planet. It is a stunning example of emergent complexity in planetary fluids. No discussion of Saturn is complete without marveling at its most defining feature, the rings. They are perhaps the most beautiful and awe-inspiring sight in our entire solar system. From a distance, they appear as solid, elegant arches. But as we get closer, we see they are not solid at all. They are composed of countless particles of ice and dust. These particles range from microscopic grains to chunks as large as houses, even mountains. Though the main rings stretch over 280,000 kilometers across, they are in most places only about 10 meters thick. The origin of these spectacular rings has long been a puzzle. The leading theory, a celestial body shredded inside Saturn's Roche limit. Tidal forces would have ripped it apart, spreading icy fragments into a flat disk around the equator. Recent data suggests the rings may be relatively young, perhaps only 100 million years old. They are divided into main groups, the A ring, the B ring, and the faint C ring, named alphabetically by Discovery. The B ring is the brightest and most massive. The A ring contains the Encke and Keeler gaps. The Cassini division separates A and B. Tiny shepherd moons like Pan and Daphnis carve gaps and create wakes, herding ring particles and sculpting waves and spiral density patterns. The rings are a dynamic, evolving laboratory for planetary physics. Saturn is not alone on its journey through the cosmos. It is the monarch of a vast and diverse kingdom of moons. At the last count, over 140 moons have been confirmed to be orbiting the planet, more than any other in our solar system. They range from colossal giants larger than Mercury to tiny irregular moonlets just a few hundred meters across. Mimas, the Death Star moon, dominated by the Herschel crater. Iapetus, one hemisphere bright as snow, the other dark as coal, complete with a strange equatorial ridge. Dark reddish material from Phoebe may explain Iapetus's darkness. Pan-Daphnis, they carve the Encke and Keeler gaps, producing scalloped edges and wakes. Janus and Epimetheus share nearly the same orbit and swap places every 4 years. Hyperion, Tethys, Dione, each a distinct world recording billions of years of history, a gallery of planetary possibilities. Among all the moons in our solar system, one of Saturn's companions stands in a class of its own, Titan. It's actually the second largest moon in the solar system, even larger than the planet Mercury. It is the only moon known to have a substantial atmosphere, denser and more massive than Earth's. In January 2005, Huygens descended through Titan's opaque clouds, sending back images of an alien landscape. Huygens revealed river channels, shorelines, vast dark plains and rounded stones, actually water ice frozen as hard as rock. Because Titan is about -179 degrees Celsius, methane can exist as liquid, solid, and gas, with rivers and lakes such as Kraken Mare, larger than the Great Lakes. Titan has a methane cycle akin to Earth's water cycle: clouds, rain, rivers, and seas. Cassini's radar mapped these seas concentrated near the poles. Titan isn't likely to host life as we know it, but it is a natural laboratory for prebiotic chemistry, a tantalizing possibility that expands our imagination. It forces us to rethink what Earth-like can mean. While Titan is grand, another moon offers an equally profound revelation: Enceladus, a small ball of ice, about 500 kilometers across, one of the most reflective objects in the solar system. Cassini revealed a secret when it flew past the South Pole. Enormous plumes of water vapor and ice particles blast hundreds of kilometers into space, emanating from long fractures called tiger stripes. These geysers continuously replenish Saturn's faint E-ring. The plumes indicate liquid water and internal heat beneath an icy shell, evidence for a global subsurface ocean. Fly-throughs allowed Cassini to sample plume material directly. They found water, salts, silica grains, and complex organic molecules, the building blocks of life. Silica suggests water-rock interactions at high temperatures, hydrothermal activity on the seafloor. On Earth, such vents support rich ecosystems independent of sunlight. Tidal heating keeps the ocean warm, making Enceladus a prime target in the search for life, a small moon that reshaped our view of habitable worlds. Our modern understanding of Saturn is owed almost entirely to one mission, Cassini-Huygens, a joint project of NASA, the European Space Agency, and the Italian Space Agency. Launched in 1997, it embarked on a 7-year journey and arrived in 2004. Huygens, the first landing on an outer solar system world. Enceladus, plumes sampled revealing organics and salts. Titan, radar-mapped lakes and seas of methane. Rings, new moonlets, propeller structures, and density waves were observed. Hundreds of orbits, dozens of Titan flybys, a masterpiece of engineering. To protect Titan and Enceladus, Cassini performed daring dives between the planet and rings. On September 15, 2017, Cassini plunged into Saturn's atmosphere, sending data until the last heartbeat. A poignant end to a remarkable journey that transformed our view of the jewel of the solar system. Saturn has always been more than just a planet, a cultural touchstone and a source of myth. From ancient observers to modern scientists, Saturn inspires awe and inquiry. It makes us stop, look up and wonder. Rings are active and young. Titan mirrors Earth with a methane cycle. Enceladus hides a salty ocean with organic ingredients. Future missions may send drones into Titan's skies or submersibles beneath Enceladus's ice. Saturn and its moons hold the promise of answering ancient questions. Are we alone? What forms might life take? When we look at Saturn, we see a beacon of possibility, a mirror that reflects our curiosity back at us. It challenges us to explore, to imagine, and to continue the story. Thank you for joining this journey today.